Hi.
Do it again. Do it again.
Oh, you stopped it?
No, I'm still recording. It'll be funny. You can cut it out. Good.
So this is my senior design project. It's a laser, as you can see. And this is all the nitty-gritty cool stuff inside. I don't know if you could zoom in on that.
Yep.
It looks pretty complicated, but it's not. That's the microcontroller that I programmed. I don't know if you can see. I can't lift it up all the way, only because like the wires are attached to the switch. Can you see it, maybe?
Not really. Do you have a flashlight?
Oh, you can see it this way. Yeah? That's the microcontroller I programmed. It's an Atmel 851. Oh no, actually it's an Atmel 16. It's an Atmega. Yeah, I know my parts. Don't worry. Okay. Alright. So, let's start by turning this guy on. Okay? That's on. You hear that? It makes a little crackling noise. Actually, let's see if we do make it cooler. I'm moving it around because it has a coordinate. Okay, ready? Turning it on. Yes. By default, when you switch that guy on, it sends a certain pulse width modulation, and that's the default position. Probably could have made it so it looks like it's like perpendicular to something, but whatever. It works. Okay, now we're going to open up HTerm on my computer. And we have to match the settings to what it is programmed to. So we have a baud rate of 9600. And I can't see what I'm doing anymore because Shweta's all up on the laptop. We have 8-bit data. There's 2 stops because, I don't know, I feel like that's safer. No parity. I think that's about it. And then we say connect, and if it's the correct connection, then it'll be fine. And we figure that out once we put angles in. All right, for azimuth, you start with an A, and let's say I want 0, 0, 0. Then our guy moves. Okay, from here you can just focus on that. And then if I push E, let's say 0, 0, 0, then the laser will come down. Nice. Okay. Now let's say I want the laser to point straight up. I want 90-degree angle. Okay, so it's not perfectly calibrated, but we did the best that we could, considering we only had one day to calibrate it. If you look up, you'll see the laser. I can turn it on. You see that? And then I can turn it off, on, off, on. And then I could also increment the laser by little pieces.
Right there.
Can you see it? And then I can have it go down. And I have to push this enter, enter, enter each time because we have to use an interface like this. Now eventually it'll be savvy enough to just, you can hold down the button and it should be able to move and not have to push enter all the time. Cool. Mommy, wow. I'm a big kid now. Okay, I'm going to turn off the laser. And that crackling noise is the digital part. The digital is more noisy than it's noisier than the analog for some reason. It's kind of annoying. Let's see. 90 degrees. Yes. And if you put an angle that's it's out of range, then it goes back to its default position. So if you want to move both at the same time, you don't have to push enter on each. You could just say A 200 degrees and E 90 degrees, and then put that all in there, and then push enter, and then it'll move at the same time. Wow, not bad, huh? Not bad. All right, that is my project. I don't know what else there is to do.
Oh,
That's my project.
awesome.
We programmed it to do that. Oh, there's also the detector, but I didn't make the detector.
That's okay. Still talk about it.
Okay, this is the detector,
Mm-hmm.
and it also has a microcontroller on it. But inside here is all the circuitry, and the microcontroller is powered. We could have done the same for this one, but it was just faster to use the starting kit as its board to hold on to it, because it's easily powered.
Can you give it a spin?
Well, no, it's actually really loud. It's like 12.
No, I mean turn it.
Oh,
So I
sorry.
can see it.
You may literally spin.
Wow, that's pretty.
Yeah, Mark Schneider did the design, and he's the one that found all the photodiodes, and it actually works. This is supposed to go onto an RC